La doctora Jean Cao. Les platico brevemente de la trayectoria de la doctora Cao. La doctora es epidemióloga molecular de cáncer y profesora asociada de cirugía y medicina de la Universidad de Washington en San Luis. Su laboratorio aplica métodos epidemiológicos rigurosos, aprovechando pues, grandes cortes, consorcios, para investigar la etiología y factores de riesgo de los cánceres de aparición temprana a lo largo de la vida. Y su trabajo lidera principalmente la línea de investigación sobre cáncer colorectal de aparición temprana, que es el tema que vamos a ver el día de hoy en nuestro seminario. Em, y bueno, el trabajo de la doctora Cao ha sido pues, reconocido por diversas organizaciones en Estados Unidos y en el mundo. Y la doctora Cao también es editora asociada del Journal of National Cancer Institute. Eh, doctora Cao, Doctora Cao, I am honored to welcome to this seminar. It's truly a privilege to have the opportunity to learn from such an experienced and knowledgeable researcher. And it's a pleasure to having you here. Thank you so much. It's your turn.
Thank you so much, Dr. Leticia Torres. Sorry if I pronounced your name wrong. I couldn't understand the majority of your introduction, but I know it's a very warm and very extensive introduction. Thanks so much. I really appreciate it. And to the audience in the room and also online, it's really my great honor to be here to present to you on this topic, which I think the goal is really to have your support in the upcoming years at the global level, that we can really move the field forward. So it's really a great honor to be here. With that, I'll take the ball and start my presentation. All right, so my title is Shaping the Future, Global Strategies to Combat the Growing Challenge of Early Onset Colorectal Cancer. Well, there are two parts that I want to present to you. The first part is it's a global call. I want to show you why addressing the growing burden of early onset colorectal cancer is important at global level. And the second part is really to show you and to call you for your enthusiasm that we really need a global call for action and how we could really collectively combat the growing burden of early onset colorectal cancer. All right, so in the past around 30 years, cancer has been increasing in younger adults, however you define it. In most places, we use age 50 as the cutoff. As you can see here, globally, early onset cancers as a group have been increasing at least 24% in the past 30 years. And if we zoom in to the top 4 cancers, this is driven primarily by breast cancer, non-melanoma skin cancer, cervical cancer, and also colorectal cancer. And specifically about colorectal cancer, and based on data from cancer incidence in 5 continents plus, we know at least 19 countries have experienced increase in early onset colorectal cancer. Looking at US, we are at the highest burden with 10 per 100,000 in terms of incidence, and this will be the #1 cancer burden among younger adults by 2030. And in the UK, even though the burden is less, not as much as US at this point, but if you look into the rate of increase, UK has a rate of increase of 3%, which is actually almost 1.5 times of that in the US. And even in places such as India, the incidence is low, and the traditionally colorectal cancer is not really considered as a major cancer burden in India. Their rate of increase is 3% in parallel with that in the UK. And based on the most recent data, which is up to 2017, and this is analysis led by American Cancer Society and also International Agency of Cancer Research, not only 19 countries, we now extended that number to 27 out of the 50 countries that we have very extensive national data. And this data is currently in press. The major finding of this particular new analysis, updated analysis, is really that these increase have been expanded to low-income countries in Asia, Eastern Europe, and Latin America and the Caribbean. So how about Mexico? Unfortunately, Mexico was not really included in the previous analysis I mentioned. So I think they missed at least one important country from that data. However, we are able to pull some data from Global CAN and other sources and global burden disease. Right now in Mexico, and this is data I think up to 2019, the burden or the incidence is 2.4 per 100,000. However, the AAPC, if you remember the numbers here, it's actually really, really high. It's at 3.7% per year. And zooming into the data in the US, colorectal cancer under age 50 is going to become the #1 cause of death for those under age 50, #1 cause of cancer deaths for male under age 50, and #2 for female, and it's projected to replace breast cancer to be the #1 cancer death burden. If you're not persuaded at this point, I think many of you may know these two people. They were recently diagnosed with colorectal cancer, and unfortunately, one of them died. So I think the message is really colorectal cancer is no longer a disease of older population. In the US, in the past 10 years, the median age of diagnosis has been decreased from age 72 to 66, just in a 10 to 15 time frame. And that continues to decrease, and we expect it's really coming to the younger generation and the younger ages. So let's move on to the second part. How could we really collectively combat the growing burden of early onset colorectal cancer? And before touching upon that, I invite you to come with me on this journey to think about 4 questions. How can we learn from the history in terms of how have we uncovered carcinogens and risk factors for cancer? Question #1. Question #2, how can we really invest life course exposome for early onset colorectal cancer? Question 3, why early onset colorectal cancer are on the rise? Do we know a lot yet, or do we know nothing? And the last question is, what can we do to really alleviate the burden of early onset colorectal cancer today? So starting with the first one, this is a very complex figure or timeline. But the goal I want to show you is this, we all know this tobacco and lung cancer causation. But if reflecting back to the history, it actually took us human beings 230 years to confirm this causation. Looking at these data, especially concentrated among 1930 and 1960, these initial epidemiology studies really set up the foundation for us to initially observe and potentially link smoking with lung cancer. And not only until after around 20 years later, the first animal study kick in, and about around 15 years later, the first genetic study kick in. So the key message here is really human studies or epidemiology study is really the foundation for us to observe and identify the link between risk factors or carcinogens and cancer. However, as a society, we have never stopped to take action. The Royal College of Physicians in the UK and UK Surgeons General back in 1960s, based on large amount of epidemiology data, claimed that there's a clear association between smoking and lung cancer. And to date, 500 carcinogens have been classified as group 1 or group 2A or 2B carcinogen. 129 are considered as group 1, basically means there are ample human evidence. What really I want to say is that even though for these carcinogens, there are so many things that we don't know. For example, for alcohol, it's a carcinogen identified as group 1 carcinogen since 1988. However, if we look into how we consume alcohol, especially in the younger generation, the lifetime peak of alcohol is actually in early adulthood. And this is coupled with binge drinking and many risky drinking behaviors. However, if you think about the context of colorectal cancer and other cancers, we actually don't really know the impact of these behaviors. Our group has put a multiple cohort based at Harvard, really looking at this question, whether early adulthood drinking is independently affecting risk of colorectal cancer independent of adulthood intake. We did find borderline association. What I want to say here is that when we do analysis, we realize even with these large cohorts, there are very limited data on early life alcohol intake and assessment. And we found that similarly across the board in other cohorts as well. Continue this story on alcohol. Some of you may notice there's a recent phenomenon with the term, some news media call it drunkorexia, which basically means to get drunk faster and to avoid weight gain. And this is really very common in younger adults. How common it is? Oh, sorry. In UK, it's around 40% for those under age 35. And across the board in many developed countries, especially common in women. So to tackle this question, are there any direct physiological impact or impact on cancer risk if we drink without eating anything? So we started looking at this. This is UK Biobank data. We did show that this is adding on top of a risk independent of total alcohol intake. And moving forward, we are really trying to see how this is together with eating pattern is really changing cancer risk. And now we thinking about risk factors, not only carcinogens, but moving to risk factors, for example, such as obesity. What I want to show in this figure is really that it really takes quite a long time, even for us to add additional 8 cancers to the initially identified 5 cancers to claim that obesity actually contributed or is causally linked with 13 types of cancers. It took us 14 years to do that. However, to date, there are still many unknowns about how obesity is actually contributing to early onset cancers, especially early onset colorectal cancer. Our group has first published study looking at early adulthood and weight change independently of mid adulthood weight and how that's contributing to early onset colorectal cancer. And this finding has been later validated by multiple cohorts, including EHR data. What is really interesting is that we actually don't know when obesity starts to play a role. Does maternal or paternal adiposity really matter? We don't really know the critical time window. And I think this is particularly relevant for Mexico, given the fast rise of incidence of obesity in children. And without knowing this, we couldn't really answer the question how much obesity is contributing to the rising incidence of early onset colorectal cancer. And what is even more worrisome, given so much we know about obesity and colon cancer in general, we actually don't really know whether colon cancer patient with prior who are obese before diagnosis or have an extended history of obesity throughout their life course, whether their molecular signatures are different from those who are not obese. We couldn't even answer this simple question, so that we couldn't really develop intervention strategies, both in terms of prevention as well as therapeutics. So that end up with my first question. The second is really how can we invest life course exposure for early onset colorectal cancer, and why does it matter? Because we are seeing very clear birth cohort effect in early onset colorectal cancer, especially in the US, basically means the younger generations are having higher risk compared to prior generation, even if they are at the same age. And they carry forward this higher risk along their life course. And so when they grow older, they still have higher risk. And this really leads us to think about how can we utilize the life course epidemiology approach to really address these questions. And here is just a revisit of these concepts. There are different models that we can use. Sensitivity period model basically means that there's a particular time period we are so sensitive to disease initiation. Accumulation model means multiple risk factors potentially accumulate their risk to a particular disease together. Pathway model, one risk factor leads to another. Social mobility, which is very important if we want to study social determinants, because our social class can change over time and with our family. Unfortunately, very few of these have been applied to early onset colorectal cancer research or early onset cancer research in general. In part because cancer is rare and early onset colorectal cancer is super rare. There's always a lack of longitudinal data across lifespan in the US and globally. There's a lack of repeated biospecimen collection. And even though we have some good cohort here in the US and across the globe, many of these birth cohorts were confined to a particular region, particular time period when the children were born. So it's very hard to know, or in terms of generating reproducible findings based on birth cohort data alone. And we all know challenges also means opportunities. This basically means, should we think about really new data collection, setting up birth cohort across the globe, and potentially trying to answer this early onset colorectal cancer question for our grandchildren? Or should we really focus on majority of our energy to think about efficient study design, leveraging existing vast amount of good cohort data, EHR biobanks, clinical, mobile data, geocoded data, and multi-omics? And how do we really make causal inference throughout the life course? G method has not really been applied too much in the life course frame. And how about life course Mendelian randomization? And eventually, what kind of system or network modeling we need in this process, really capturing what's changing throughout our life course and their impact on disease and cancer specifically. And I think all these questions really means a lot of opportunities, both at local and global level. Can we leverage these bi-directional interaction to potentially push the field forward, help our younger generation? I don't have an answer specifically, but I want to put these opportunities and challenge to you so that we can think together. All right, so because of many of the risk factors we know about early onset colorectal cancer or colorectal cancer per se, seems doesn't to be the whole picture. So there's a huge interest to look into this concept of activism and how we can really look into everything we are exposed to. And this is a concept initially brought up or created by Dr. Chris Feld, the director then for IARC. And the idea is really to look into everything environmental, everything non-genetic, as drivers of health and disease. And over time, this concept has been really involved based on how much we can measure. And we broadly separate them to internal activism, as you can see, many omics, etc., and external activism. But the key challenge over time is always this one, the functional activism. And from there, how we can really infer exposures, especially when many of the factors are mixed together. I don't have a specific answer to this, but I want to present to you 3 frameworks that potentially are being advanced by a lot of people and very exciting, and I think need a lot of talent from the field to really help push it forward too. So the first one is really tissue mutational based framework to infer risk factors. And this slides basically show the cosmic mutational signature. It has been utilized to analyze large amount of genetic data for us to really understand the molecular signatures within a particular tumor. And it's based on genetic variations, etc. And this framework has been applied through the Cancer Grand Challenge team Mutograph to early onset colorectal cancer. What they have done is really to look into whole genome sequencing data from around 1,000 colorectal tumors from 11 countries with various incidence rate, as you can see from all over the world. What they found is that this Colibactin signature, which is called SBS88, resulting from PKS E. coli exposure, is more enriched in cancer diagnosed at younger ages. Although number is really small, but you can see a quite clear trend here And the team is continue to develop, to validate these findings in more samples, but more to identify the source of these Caulobactin signature. And I forgot to mention the important assumption underlying this cosmic signature is that everything we expose to will have a signature in our tumor tissue. So because of this, they can utilize this framework to infer exposure. But there are inherent challenges for this particular framework. And this is really based on advanced understanding over the past 5 years on both normal and tumor tissues. The first one is that we do see high level of genetic mutations in normal tissues. And second is that when we put these carcinogens, as I mentioned, the 500 carcinogens, but they actually tested 20 here in the mice, they actually doesn't really generate distinct mutational signatures in animal studies. So the bigger question here is that how most carcinogens we identified from human studies with some animal study support, how do most of these carcinogens induce cancer if they are not mutagenic? Basically, they didn't leave any signature at the tissue level. So that's the big question that many people are trying to advance at this stage. The second question is how we leverage potentially archived blood for metabolomics, or more general called small molecule profiling, to infer risk factors. Those in epidemiology are aware that in the past probably 2 decades, we have been utilizing archived blood in the cohorts, in large prospect cohort, and trying to look into whether different metabolites are predictive of cancer risk. We learned a lot, but the challenge of this framework, even with the advancement of LC-MC technology, is really that the vast majority of the signals we see are redundant signal. And among the very small amount of very unique signals, very few of them are known metabolites or chemical exposures. There are quite a lot of novel exposures, but it's very challenging to isolate these chemicals to really test whether they causally induce cancer or promote cancer. So there's a huge challenge in this field. And the last one, I want to show you this increasing interest in microbiome. And there's a lot of people hypothesize that microbiome is really the mediator between the exposure and increasing risk of early onset colorectal cancer. However, so far we have not been so successful using stool microbiome signatures to infer any risk factors. And this is in part because of the limited study design or limited data from the field, that in most cases we just compare colon cancer patients or a few years before their diagnosis versus controls. So there's a huge lack of prospective studies in microbiome research, so that we couldn't really figure out whether these metagenomes or specific bug, are they really drivers of colorectal cancer or any disease, or are they passengers of this process? And one approach people use is to meta-analyze a bunch of data sets and trying to see if there are consistent signals. And this is the figure showed on the left, showing that there are 29 species significantly enriched in colorectal cancer metagenomes. But again, it doesn't really answer the question whether these metagenomes are drivers or passengers of the process. And in the microbiome community, there's a huge advancement in terms of trying to link exposure, which include very basic characteristics such as antibiotic use, smoking, and things like that, and how that's associated with particular microbiome signature. And this data set is called, or database is called BACSIC-DB. It's a community editable database so that you can input all your phenotype data and microbiome data, and eventually with the goal that whether we can use this signature to infer relevant exposures, similar to the framework I show that were based on tissue level and tissue mutational signatures. But as you would imagine, this database has inherent issue in terms of the study design, that we could not really figure out passengers and drivers of a disease process if we don't really have longitudinal data. So these are some of the work that are ongoing in the field. Many of them, I think, it's super exciting and really highlight the importance of advancing in each of these fields. So do we really know how early onset colorectal cancer and why early onset colorectal cancer are on the rise? In the past several years, my team has led a field work in this space, looking at metabolic conditions throughout the life course, as well as diet in various formats, including dietary quality, sugar sweetened beverage, and sulfur microbial diet. Basically, we annotate the stool and trying to link diet with a class of carcinogenic bacteria called sulfur metabolizing bacteria. And then we use this score to really link in another large cohort, and trying to link that with precursors of early onset colorectal cancer and colorectal cancer, and we do see association. So it's really a proof of principle study showing that microbiome potentially can be a mediator between our diet and cancer. We also stretch a little bit, looking into emerging exposures that are potentially relevant in younger generation, but largely overlooked in our prior research in colorectal cancer, including sedentary behavior, drinking pattern, as I mentioned. And we also look into births through C-section and identified a higher risk among individuals who are born, especially women who are born through C-section, and substantially higher risk in early onset colorectal cancer as offspring, but there was no association for men. So some of the work we are doing, as mentioned, we are very interested in common emerging exposures in younger generation. We are heavily invested in circadian rhythm dysregulation, looking at different types of data from wearable devices. And this is the first pilot we have done is UK Biobank data, looking at 85,000 accelerometer data from UK Biobank. First, we want to see whether there's a generational shift in terms of circadian rhythm dysregulation, and whether it's associated with risk of GI cancer. And we are very fortunate to see both. So as you can see on top, the younger generation have worse circadian dysregulation in general, and this is associated with colorectal cancer more specifically. And up to this point, and along this process, in the past 7 to 8 years, when we talked to oncologists and many health providers, they did tell us many of their patients don't really have the risk factors. Many of these traditional risk factors, they don't have them. So what's going on? And to that extent, we are really fortunate to be funded by Cancer Grant Challenge, which really highlight the importance of causal risk factor identification, not only looking at the impact of what we have found before throughout the life course, how these risk factors really play a role throughout our life course, but among those without risk factors, how can we really push forward trying to help these populations to identify causal risk factors so that we can really prevent colorectal cancer. And this is Team Prospect, funded by Cancer Research UK and NCI, and Baobab Fund, which is a patient organization, funding organization, and also French National Cancer Institute. And the team really means pathways, risk factors, molecules to prevent early onset colorectal tumor. And this is led by myself from WashU and also Dr. Andy Chen from Mass General Hospital. On the left is a picture we took during the interview stage. On the right is our kickoff meeting in Boston. Some of you may already seen Dr. Martin Largos there, and we are so fortunate to have his support and his team's support along the way. So what is Cancer Grant Challenge? It's a global research initiative that aims to empower the global cancer research community to come together most importantly, to think differently and to solve cancer's toughest challenge with an overarching goal to transform outcomes for people affected by cancer, as co-founded by Cancer Research UK and NCI in the US. We have gone through a very competitive process from over 170 teams to 12 teams invited for the interview and 5 teams eventually founded. And we are the only team globally to be founded on early onset cancers to address the early onset cancer challenge. And we are extremely proud not only to bring St. Louis, India, but also Mexico to this Cancer Grand Challenge community. As you can see on the right, so far 16 teams have been founded by this mechanism across more than 16 countries and over 1,200 investigators and collaborators involved. All right, so this is really the core team, and we are really supported additionally by more than 30 collaborators, including 30% early stage, and 30 future leaders, which include Dr. Liliana Gomez, and more than 15 cohorts of biobanks. As you can see, this is a very interdisciplinary team. I'm a cancer epidemiologist. Dr. Andy Chen also works in cancer epidemiology, but he has a huge focus on cancer prevention trials. And we do have chemists who are leading exposomics and cancer metabolism. We have a couple of computational biologists who are pioneers in computational pipeline for microbiome research and also microbiome transmission. We have Emily Bauskas, who is a chemist who first looked into microbiome from the lens of chemistry. So she's able to design small molecule inhibitors and identify the causal microbiome and also the causal enzymes that play a role in this whole cancer initiation and progression process. We have Jason Brydrostro, who is a cellular biologist, and he is one of the first person who developed ATAC-seq, which is widely used epigenome research and single cell research nowadays. We have Yasmin Balkade, who is the president of Institute of Pasteur, an immunologist who had invested her career on life course infection and risk factor and how that affect immune system throughout our life course. Dr. Omar Imez is a stem cell biologist who is a pioneer in looking at how diet is really affecting colon cancer stem cells. We also have global oncology leaders, Dr. Sarohi, and she has really been a driving force in India, pushing forward a lot of infrastructure building in India, not only in medical oncology field, but also in cancer prevention. Dr. Tim Spector is a precision nutritional epidemiologist and leader in genetic epidemiology as well. He has APP that potentially can reach so many younger population in both UK and US has been utilized to collect data during COVID period. All right, so the goal, as you could imagine for this team, is really to advance correlation to causation for actionable prevention among younger generations. And how do we achieve that? On the left, you see we want to really narrow down from exposome to causal factors and eventually to help with prevention. So what we are doing here, the first objective is really to look into life impact of established and novel risk factors through global and diverse cohort. And specifically, we'll look into everything you could think of, from established risk factors for colorectal cancer and early onset colorectal cancer to anything in the environment, in the chemical environment, natural built environment, social determinants, geocoded data that are collected through all these cohorts. And we'll look into the impact of these risk factors if longitudinal data are available throughout the lifespan, and how they affect early onset adenoma, which is precursor for early onset colorectal cancer and early onset colorectal cancer. We'll also utilize archive biospecimen for discovery on small molecules. We'll also look into how microbiome may be different from those who had the disease, as well how microbiome relevant to colorectal cancer are transmitted across social network, across different risk factors. And our goal is really to identify novel risk factors, microbiome signatures, and potentially risk assessment tools. All right, and here is the major highlight of this global consortium of more than 10 million population. We're so fortunate to have Martin's support and support from Mexican teachers cohort, and it really allows us to have the opportunity to not only look into data from a particular low and middle income country, but really this is the first in the field, as I mentioned, the first time we bring Mexico to Cancer Grand Challenge, to this global cancer community. To me, that has enormous meaning. We hope through this process, through harmonizing all these data across the globe, including MTC, a lot of large intergenerational cohort, integrated health system cohort from different biobanks, twins registry, as well as a cohort of African American women and a lot of citizen science cohort based at UK. We really hope to find risk factors that are common and also those that are different, that are context-based for particular geography, so that we can really help push the field forward to develop country-specific, region-specific prevention strategies. And for us, we also understand that this is the first time that the MTC has been engaged in a colorectal cancer specific project. And we really cherish this opportunity to work with Martin's team to really bring not only MTC to the global stage, but hopefully finding something meaningful for your population down the road. So the second objective is really focusing on causal mechanisms and biological networks. So what we will do, again, we'll actually collect clinical specimens from MGH and also WashU, and we'll conduct deep chemical functional profiling of these specimens. And we'll develop life course animal models and in vitro human models with the goal to really humanize our mechanistic research and find human-animal convergence so that we can make an action. And both Objective 1 and Objective 2 will utilize a lifespan approach, which really extended the framework that has already been in the field for many years. So more specifically for this human work package 2, we'll specifically look into causal we'll collect biospecimens along the continuum of colorectal cancer development from normal colon and normal tissues and colorectal cancer, with the goal to identify causal small molecules, causal microbiome mediators, and cellular and regulatory circuits, cell regulatory circuits. And I'll skip the animal model, but just in brief, we'll build life course animal models, which means their exposure. For example, again, using obesity as an example, we all know adult life obesity important, but whether really maternal, paternal obesity had an imprint on the offspring on risk of early onset colorectal cancer is not clear. So we'll build different mice cohort to really reflect human exposure across the process. So the other exciting part of this grant is that we are going to conduct 3 clinical trials and 1 community experiment in both US, UK, and India. We'll test out specific medications, interventions such as GLP-1 and how that's reducing molecular signatures related to colorectal cancer. We'll conduct a trial among UK twins and trying to see dietary intervention really changes microbiome signatures that are relevant to colorectal cancer. We'll conduct another community risk assessment trials in the UK with the goal to engage younger population for behavior change, and this will use mobile app, as I mentioned before, and really trying to identify the barriers for people to change and sustain behavior change. And in India, we'll help them set up the infrastructure for screening because they don't really have a screening guideline in place. So what we would like to do is to leverage their local resources, such as screening camp, but provide information and communication related to colorectal cancer risk. and to see if that really boosts up screening based on FOBT, and also collect biospecimens so that we can further refine the risk assessment and help them really moving toward more high-risk screening based on their particular context. All right, I'm also very excited about that we had a global and diverse patient advocacy team. And Martin and I have also been thinking about trying to identify a patient advocate from Mexico. So if any of you have any resources, please help. So far, we have been interacting with these patient advocates for the past 1 year, and we learned enormous from them. Many of them are trailblazers in their field. They wrote books, they are elementary teachers, and trying to bring colorectal cancer awareness to their local community. And some of them are very new to patient advocacy. While in common, they have never been engaged in a research team that solely focuses on cancer prevention and etiology or risk factor discovery. This is a mental challenge for them, but they are super engaged to help us to really humanize our research that potentially have impact for younger generation, because they really care about their children and family. They want to help as much as they can. So we really are so grateful for the opportunity to engage this two-way interaction with our patient advocacy team. We also had a very strong and visionary external scientific advisory board that have been really helping us to shape the way we understand data, harmonize data, but also really the outlook moving forward in terms of how we can really accelerate the process of cancer risk factor discovery so that we can potentially help with the younger generation as fast as we can. All right, so my goal for this particular project, of course, innovation is our goal, but as I mentioned, we want to interact with broader community, including patient community and the public. We want to incubate potentially new field, especially also bring in many low and middle income countries who had really great cohort that has not had a chance to really engage in global or like these type of cancer risk factor discovery research, so that we can really work together and try to identify context-specific risk factors. And most importantly, we want to inspire and utilize this opportunity to help the future leaders to get a sense of what is global cancer prevention research and team science, and potentially take lead on greater challenges. And these are future leaders presenting at our kickoff meeting in Boston. And this is Liliana with me and Martin and my colleague, Dr. Andy Chen, a program officer from Cancer Grant Challenge. And we were at the Cancer Research UK reception at the AACR. And Liliana is also going to Barcelona to present our team as future leader to the Future Leader Conference organized by Cancer Grant Challenge. All right, so coming back to a little bit of my own research, as I mentioned at the very first page, there's also, other than colorectal cancer, a lot of cancers have also been increasing worldwide in both developed and developing countries. And one thing we are super interested in pushing forward and also find collaboration is really to, in this space, trying to think along the way that how we can think cancer as a systemic disease, and what signal from there we can really help with cancer prevention. And you all know I talk about individual risk factors, which is really environment here, and through single cell and spatial analysis, we know so much about microenvironment, but what is really missing is this middle part about microenvironment, how we can utilize blood signatures, body system signatures to really help identify disease much earlier, in particular cancer. So in that front, my PhD student is leading a couple of research in the realm of accelerated aging. We want to bring this concept that are readily used in aging research, but not in younger population, to see, I guess, first two questions. One is whether younger generation have accelerated aging, and how that's associated with early onset colorectal cancer and other early onset cancers. And eventually we want to develop using proteomics and other omics to develop organ-specific aging clock so that we can utilize blood signatures, protein signatures, or multi-omic signatures to really identify specific organs that are more affected and how that's linked with cancer risk. All right, the last part about this, I think it's also important for us to think about framework for evidence synthesis. And just a thought in this field is that a lot of times we talk about PAR, population attributable risk, but that concept is really time independent. That doesn't reflect at a particular population in terms of how much we can intervene and potentially and prevent cancer. We only know a number, but that number doesn't reflect the population prevalence and how much can be changed. And also as well as the cumulative impact of a particular exposure over life course. So to extend this framework, we work with NCI SysNet modeling network. It's a network where we utilize that to develop US cancer screening guidelines through this micro simulation model on the right. This is specific for colorectal cancer, but they also have macro simulation for other cancers as well. The big picture here is that it's a natural history-based model. So you are able to identify the contribution of the risk factor or screening or chemotherapy to colorectal cancer so that you can model the whole process. And what we are doing with this framework is that we want to leverage the extended national data on obesity and can do other risk factor too. But the goal is really to see how generational-wise obesity has been changing across life course by race, by ethnicity, and also by cumulative exposures. As you can see, just for example, in non-Hispanic Black female, the younger generation who were born in 2005, they had a much earlier exposure of obesity throughout their life course. If you just look at data at age 65, they're pretty much the same across all these birth cohorts. But people come from this stage at age 65 from different paths. This is well ignored in our prior research, and I hope this framework can be potentially helpful for us to fully understand how much obesity and other risk factors are potentially contributing to a particular disease, especially early onset colorectal cancer. All right, so the last part, what can we do to alleviate the burden of early onset colorectal cancer today? It's important to note, however, in whatever way we change cancer screening guideline, the uptake is very low for younger adults as well as racial ethnic minorities. So this really shows a colorectal cancer screening uptake in the US by 2021. As you can see, even in this age group, age 50 to 54, because we have had this guideline for many years, and this group had substantially lower uptake compared to older age group. And if you look into by race and ethnicity, there's a huge difference in terms of uptake and preference of test by race ethnicity, so, which also means there's a lot of opportunity we can help the community really improve this. At the same time, while realizing screening will not be the eventual solution or the only solution for this, it's also important to realize a lot of trials have been done for aspirin, vitamin D, etc., across the globe, primarily in the US. But none of these have been put into the framework and how we can apply these to early onset colorectal cancer. And before we do that, there's evidence gap, clinical guideline issues to consider, and also awareness and resources limitations. Finally, I want to emphasize early detection is extremely important. A lot of early onset colorectal cancer are diagnosed very late in stage, so they don't have a great prognosis. Even if in the US, we move screening guideline to age 45, as I mentioned, it's not going to be perfect. But even if it's perfect, as you can see in this pie chart here, 52% will be diagnosed under age 45. So screening won't cover them. So using simple signs and symptoms is potentially an efficient way, or at least a solution to this very important issue. Whether we can increase awareness for the general public, younger adults, and also provider level to utilize to well recognize these signs and symptoms before diagnosis is very important. This is a research from our group being highlighted by the NCI as the top 10 research back in 2023. The idea is really to see how these typical signs and symptoms for early onset colorectal cancer really go back in time. And we did find up to 2 years before diagnosis, many of these signs and symptoms are being showed up. And a lot of delay in diagnosis is really from both provider level and also the patient level. All right, so I think hopefully you are persuaded is that we need a lot of research at molecular level, maybe even early detection tests, etc. But it's very important that we raise awareness and trying to think about having disparity in mind so that we can really prioritize things we already know and get them implemented for younger adults. All right, my last page, and it's a early onset colorectal cancer is a global problem, and we need better frameworks based on biology, from risk factor identification to risk factor integration to evidence synthesis. And we need to implement interventions that we already know that potentially could work. And we need all across the globe to drive this revolution. With that, I'll conclude, and a special thanks to Martin, Liliana, and Dr. Leticia and Torres, and for everybody in the room online, and for colleagues from MTC and NSP. Thanks so much.
Thank you so much, Dr. Cao. I am personally very impressed with the presentation because you bring to us the full picture of the problems and the full picture of the challenge to overcome this increase in colorectal cancer, but also it's stimulating that, for example, here we are in the School of Public Health, and I think that it is very stimulating for all the students and all the researchers who work here, because there are a lot of work to do, and I am also very excited because I heard that there are a lot of new frameworks that we have to learn, that we have to test. And I don't know if in the audience we have some question, but in the meantime, I would like to share some questions that bring to my mind. And as you said, we don't know several things about this cancer, but something that highlight my attention is that you said that we don't know what is the critical window for the early onset colorectal cancer. And I'm, since my perspective of epidemiologist, I am thinking about what can do since from the academia to solve this question.
Yeah, that's very important question. I don't have a perfect answer. I think generating more longitudinal data will be very helpful. I know MTC had some recall of early life factor as well, but I think we need more and more to help in terms of emphasizing we all come to a particular disease stage through extensive life course history. So we really need to, not only in academia, we want to understand or build framework how we can utilize life course epidemiology to solve the question. But in our field work, we should also emphasize the importance of repeated biospecimen collection and data collection. Unless we have the data, it's very hard to make any inference in terms of how we can help people prevent disease, especially at younger ages. It's a very important question.
Thank you so much. Yeah, I think that it's important, but also it's very hard to
Exactly.
Yeah, and also I'm just thinking about the situation, for example, from Mexico, where we don't have an colorectal cancer screening program. So, and I'm just wondering, what should do if we should start identifying high risk groups with what kind of tools to, I don't know if we can offer the screening to all the population, to the whole population. What can I do to start doing something about this to prevent this cancer?
Yeah, I think it's developing the country or context-specific screening framework. I think it's very important, but at the same time, identifying high-risk population. Again, it's also based on data. Who are really at high risk, and how can we reach out to these high-risk populations sustainably, right? And would one-time screening really work for these high-risk population? From our work with India, I think our current perception is that even once probably might change, and because people really talk to their community, etc. So there's a lot of community-based awareness being spreaded if this is something being brought up to their radar. So I think there are a lot of different ways, and we really look forward to learning from the field actually, in terms of how we can from academia try to push the real world implementation forward. I think that will really take some time, especially challenging for many countries, both developed and there are even in some developed countries, the screening guideline is not perfect, starting from age 60, right? So how we can really utilize evidence to really guide this is something really, really challenging. But first, I think we need some evidence. It's not something that we could just think out of head.
Okay, thank you so much. And this seminar, was organized in collaboration with the association from the Mexican Association from Gastroenterologists, and I would like to know, since the perspective of the clinicians, what they can do in the meantime while we are waiting the answers to what kind of risk factors are affecting more for this cancer, what they can do in the field.
I'm not a clinician, but I'll try my best to answer this. I think first, they are the major driver for early detection and awareness as well in the community. So if there's anything they can help, I think we would really cherish that effort. And second is that, as we mentioned, evidence is very important. Even looking at the few papers I presented on international data of countries that are affected by early onset colorectal cancer, unfortunately, Mexico is not there. But as I talked to many colleagues there, I think there's a clear picture that you are probably also one of these countries. So how the clinicians can really help collect the data for us to really understand where things are with Mexico. I think broadly that would be super, super important. And the third is that related to screening guideline in terms of what screening will be most feasible for your specific context. I think clinician, especially gastroenterologists, will be leading a major role there. And their work will be phenomenal, not only to Mexico, I think to the world as well.
Yeah, I completely agree with with you. So I think that the time it's over. So I just want to say thank you so much for your time, for share your knowledge with all of our audience, and I'm really happy with this very stimulating presentation. Thank you so much.
Thank you so much. Thanks so much for having me.
Bye. Gracias
Bye.
a todas y todos los que nos acompañaron, y los invitamos al siguiente seminario de diciembre. Nos vemos pronto.